Alright, in this video we're going to go over questions 6 through 10 of the June 2014 Algebra 1 Regents exam. So question 6. The table below shows the average yearly balance in a savings account where interest is compounded annually, no money is deposited or withdrawn after the initial amount is deposited. Okay, and the question asks us which type of function best models the given data. Okay, so one thing to point out is anytime you see interest is compounded annually, that pretty much always means exponential growth. So exponential growth is the first thing you should think of when you see compounded annually. But what do we do if we don't know that? Okay, so there's two parts to this. So if we look at our answer choices, they want us to pick first, is it either linear, which is options 1 and 2, or exponential, which is options 3 and 4. And they want us to pick whether this is negative or decaying, those two are kind of synonymous, or whether the growth is positive or growth, which is also synonymous. Okay, so let's first see, is this positive or growth, or is this negative or decay? So what happens year after year to the balance? So from year 0 to year 10, we see growth. From year 10 to 20, growth. Year 20 to 30, growth, and so on. Every year, this account, the balance is growing. So negative rate of change would not make any sense. So option 1 is out. And exponential decay would not make any sense because, again, the account is growing, so it's increasing. Okay, so now is this linear or is this exponential? So in order to figure that out, we have to look at by how much is the balance increasing every year. In order for this to be a linear function, the growth has to be constant every year. So we can actually calculate the growth. So let's do that by subtracting first 562 minus 380. We don't have to be exact here. We're just trying to get a sense of by how much is it growing. So from year 0 to year 10, the growth was about $180. Okay, now let's see what happened between years 10 and 20. So how much was the growth there? So we're going to do 832 minus 562. And that's a growth of about $270. Okay, so already it's not constant growth. Let's just check one more to really verify to ourselves. So let's look at what happened between years 20 and 30. So we're going to do 1,232 minus 832, and that's a growth of about $400. You can continue to do this and you'll continue to see that the amount of balance increase every year increases. So first it started at from 0 to 10, $182, then $270, then $400, it'll keep going up. All right, so that indicates that this is exponential. This is growing exponentially, not linearly. So the correct answer here is 4. Okay, let's go on to question number 7. So a company that manufactures radios first pays a startup cost and then spends a certain amount of money to manufacture each radio. If the cost of manufacturing R radios is given by the function C of R is equal to 5.25 R plus 125, then the value 5.25 represents which one of these? Okay, so this is the equation that we have, and they told us that this models the cost of manufacturing. Okay, they told us they have a startup cost, and they told us that R is the amount of radios that they're making. Okay, so I want you guys to see how this equation is the same as the equation of a line in y equals mx plus b form, which is slope-intercept form. So this 120 looks exactly like b, which is our y-intercept. And that b, that y-intercept, I want you to think of as the start or initial, things like that. That's our starting point on the line, okay? And then the r corresponds with x here, which is what we're inputting into the equation to get y, right? To get y, to get some output. And then we have the slope, and that coincides with 5.25. And when you think of slope, I want you to think of as I want you to think of slope as the rate of change, or think of it as how much per something. So amount per something, so number per something. So I'll explain a little bit more what I mean by this. Okay, so sorry, these are close together, but that slope should represent the rate of change, the amount per something, the rate at which something is increasing or decreasing, things like that. Okay, so let's go back to the problem. So they're asking us, what does that 5.25 represent, right? We already said that coincides with the slope, which we said to think of as the rate of change or the amount per something. So let's see which one of these describes that in the context of this problem. So number one, the startup cost. So the startup cost would actually coincide more with the value 120, right? We said that 120 coincides with the y-intercept, and we said to think of the y-intercept as the start or the initial of something, right? Startup cost is the start. So that would not be it because they're asking us about 5.25. So let's see, number two, the profit earned from the sale of one radio. Well, this equation is telling us the cost of manufacturing, not any profit or revenue, so that would not make sense again in the context of the problem. Three, the amount spent to manufacture each radio, right? This is the per radio cost. That makes a lot more sense, right? We said amount per something for each radio. So that's very likely the answer. Let's just make sure and check number four. So the average number of radios manufactured. No, they told us that R is the number of radios. So that would not make sense. So 4 was out. The correct answer here is 3, the amount spent to manufacture each radio. Okay, let's move on to number 8. So number 8 says, which equation has the same solution as x squared minus 6x minus 12? Okay, basically one of these 4 answer choices we're going to be able to rewrite to look exactly like this, in this exact form. Okay, the question is which one of these? All right, so we could go through each one, expand it out, and try to manipulate each one of them to see, but let's try to take a small shortcut. We see in there, these are in pairs. So one pair is 1 and 3. Those both have the x plus 3 squared in them. And then the other pair is 2 and 4. Those both have the x minus 3 squared term in them. So let's first FOIL out each of those, and we'll go from there. Okay, so x plus 3 squared, right? We're going to FOIL these out. I'm just going to write out the quadratic equation that we get from that. You can pause the video and FOIL it out to prove it to yourself, but here's what you're going to get. X squared plus 6x plus 9. Okay, and then when we FOIL out x minus 3 squared, we're going to get x squared minus 6x plus 9. Okay, so before we do anything else here, let's actually compare these two to our original equation up here. Okay, so in both of these equations, we have the x squared term, which we have in the original equation. All right, perfect. And then the next term, first, here we have a plus 6x, and here we have a minus 6x. In the original equation, it's a minus 6x. So that should indicate to us that this is most likely where we're going to find our answer. Right? Any answer choice that has this x plus 3 squared term is not going to be our answer, right? Because we're already mismatching terms, and we haven't even gotten to that constant at the end. So we're going to cross out 1 and 3. Those are not going to be our answers. Okay, so now we know that it's going to be either 2 or 4. Okay, so when we FOIL this out, we get x squared minus 6x plus 9, right? We showed that right back here. Okay, so option 4 says that's equal to 21, and then option 2 says that's equal to 21, and then option 4 says that that is equal to 3. Okay, so we know we have to get a 0 on one side of the equal sign, so let's actually do that and see where that gets us. So here we subtract 21 from both sides. That'll leave us with x squared minus 6x minus 12 equals 0. Right? We can actually stop there because that's exactly the original equation. So we know option 2 is going to be our answer. Right? So let's look just look at answer 4 to see why that one's wrong. So we subtract 3 from both sides. We're left with x squared minus 6x plus 6 equals 0. That is not what our original equation is, right? It should be x squared minus 6x minus 12. So we know 4 is not the answer. So up here, the correct answer is 2. All right, let's look at question number 9. So a ball is thrown into the air from the edge of a 48-foot high cliff so that it eventually lands on the ground. The graph below shows the height y of the ball from the ground after x seconds. Okay, so we know y is height and we know x is time in seconds. Okay, so now it's asking us for which interval is the ball's height always decreasing. Okay, when you see decreasing, you should be thinking of negative slope. And negative slope looks like a diagonal line that starts high and ends low. So that's a negative slope. Right? That's the same thing as decreasing. Right? And then a positive slope is the opposite. You're starting low, ending high. That's a positive slope, and that indicates increasing. Okay, so let's see what's going on here. So from the beginning to this point right here, which looks like it's at 2.5, we see just positive slope. So this whole time we see increasing. Okay, and then after that we see pure negative slope. Okay, so that entire time we have decreasing. Right, we have decreasing between 2.5 and where it touches the ground looks like 5.5. Okay, so now let's look at these answer choices. So number 1 says interval between 0 and 2.5. Is it always decreasing during that time? No, that's actually the time it's strictly increasing, right? That's what we just looked at. That time is strictly increasing, so that's not the answer. Let's look at option 2, 0 to 5.5. Okay, so it's asking us where is it always decreasing? In option 2, it's increasing between 0 and 2.5, so that cannot be the right answer. For 3, we have it's always decreasing between 2.5 and 5.5. Yeah, that's exactly the interval that we designated as always decreasing. And then let's just look at number 4, when x is greater than 2. So x is greater than 2 starting from here, but we still have a small region where this is increasing. Right, so that would not be the right answer either. So here the answer is 3. Okay, now let's look at question 10. All right, so it's asking us what are the roots of this equation here. All right, so the roots basically is just what can we plug in as an x value to make this equal to 0. So normally we would factor this out. We would get two things like this, and then we would figure out what the roots are from there. But here we cannot do that. We're not going to try to factor it manually because in all of the answer choices we see that there are radicals. And when you see radicals as answer choices, that should be an immediate indication that you need to use the quadratic formula. Okay, if you don't remember the quadratic formula, I'm going to write it out here, but you do need to know it for the exam. So it's negative b plus or minus the square root of b squared minus 4ac. The whole thing divided by 2a. Okay, so it's one thing to know what the formula is, it's another thing to know how to use it. So let me just quickly show you how we would use this. First, I'm going to write out a typical quadratic equation. So that would look like this. A to the x squared plus b to the x plus c. Okay, that's just a standard form of a quadratic equation. And now let's write our equation right below it. So we have x squared plus 4x minus 16. Okay, so we're actually just going to match up the terms. So a is whatever is in front of the x squared term. In this case, it's 1. Right? If there's nothing there, we know it's just 1. So our a is equal to 1. Okay. For b, it's whatever's in front of the x term, and we always take the term, the number, and the sign that it has. Right? So here would be a is equal to positive 4. Okay, and then c is just the constant you have at the end. Again, you take the number and the sign. C is equal to negative 16. Okay, so we know what A, B, and C are. Now we just have to plug it in to the quadratic formula. And let's do that right here. So it's negative 4 plus or minus the square root of 4 squared minus 4 times our A term is 1 times C, which is negative 16. Okay, and the whole thing divided by 2 times 1. All right, now it's just a matter of simplifying as much as possible until we get one of the answer choices that we see here. Okay, so first let's try to simplify everything we can. Okay, so we have negative 4 plus or minus the square root of something in here. Okay, so we're going to want to plug this into our calculator. 4 squared is 16 minus 4 times 1 is 4, and then we have 4 times negative 16, which is going to leave us with a negative 64. Okay, so that's what we simplified inside of the square root sign, and then 2 times 1 just remains 2. Okay, and so we're going to continue simplifying here. So plus or minus the square root of 16 minus negative 4. If you're subtracting a negative number, that's the same thing as adding. So here we can also think of this as 16 plus 64, which would leave us with 80, square root of 80. And that whole thing divided by 2. Okay, so now the next step we want to take is actually divide this into two different fractions, right? Since we have this plus or minus thing going on in between, we can actually write two separate fractions. One would be 4 over 2, and that's still plus or minus square root of 80 over 2, right? All I did was write two fractions where we kind of shared this 2 here. Okay, so now we can continue to simplify. Negative 4 divided by 2 should give us just negative 2. So already we can cross out options 1 and 2 because those have a positive 2. Okay, so we know it's either 2 or 4. If you didn't know what else to do here, since you still have a plus or minus square root of 80 over 2, now at least you have a 50-50 shot. But we want to try to get every answer correct that we can, so we're going to continue to simplify this. Okay, I'm going to rewrite this over here where we have a little more space. Okay, so we have negative 2 plus or minus the square root of 80 over 2. Okay, so we need to simplify this square root 80. A lot of calculators can just simplify this for you. You can just plug it into your calculator, and some of them will give you a simplified version. But if you did not know how to do that, here's what you would do. You want to pick two factors of 80, one that is hopefully a perfect square. So this would just be a trial and error process, but I'm going to tell you right now that 16 times 5 would give us 80. Okay, so one of those is a perfect square, right? 16 is a perfect square. So we can actually take the square root of 16 and write that outside of the radical. So that would simplify down to 2 plus or minus 4 square root of 5 over 2. Okay, we're almost there. So now we can just divide 4 divided by 2, leaving us with 2 square root 5, and that is our final answer, which coincides with option number 2. So it's kind of a long process, but as long as you know the quadratic formula and you can plug in and keep track of all your numbers here, you should be able to get to the correct answer. But you do have to know the quadratic formula and how to use the quadratic formula. All right. If you found this video helpful, leave us a like, subscribe, and follow us for more videos for both math and science regions, and continue to watch the videos on our playlist.